So once you rewrite this, and then you're about to start finding the derivative, what rule are you applying first? Sierra? Power, good. Followed by the, what rule, Megan? Chain, because we have to multiply by the derivative of what's inside. And do you have the derivative of what's inside?
No, I didn't. 9x squared plus 1.
Good. So then, we can go ahead and just evaluate right off the bat if you want. That's the beauty of evaluating versus just finding the derivative, is that I don't have to worry about simplifying and making the form match anything. I can just evaluate this now at an x value of 2. So if I plug in 2, Sonny, what's your question?
I'm guessing no calculator with this part too?
Correct.
Are you giving me other clues?
Evaluating, yes.
What did he just say?
If we would have a calculator for this. You won't need one. So when we clean this up, inside this set of parentheses, what does that all simplify to? 3 times 8 is?
24.
Plus 8 more? 32. Half of 32 raised to the negative 4/5 power.
That's a point.
Extra point, it's 1/5, not half. Do I get you?
Wait, where?
You said half of 32 is a negative 4/5.
Yeah, you did say half.
32 is a negative 4/5.
Actually, she wrote it down.
Oh, I wrote 1/5, I said a half? Oh, sorry, it's verbal error. Nope, that doesn't count. 9 times 4 is 36.
I honestly agree with her.
36 plus 4 is 40.
You can't.
So your half times, or your, I did it again, your fifth times 40
Give me one.
is just 8. And then the only tricky part about this is 32 to the negative 4/5, which we don't, raising something to a fractional power in our head is, you usually wouldn't think of it as the fractional power. You would change it to a radical. So this is going to be 8 over 32, and rather than writing it to the 4/5 power, that's going to be the 5th root, then raised to the 4th power.
That's 16. That's 16, isn't it?
It's 16. The 5th root of 32 is 2. 2 to the 4th power is 16, so it ends up being 8 over 16, which is 1/2. So it's, because we've been kind of wrapped up in the rules in finding the derivative, it's been a while since we've reminded ourselves what the whole derivative calculation is for. And so I'm just going to graph this function. And we just found what we think to be the derivative or the slope at the point 2, 2. So first and foremost, if we graph this function, it should go through the point 2, 2. And the slope at 2, 2 should be about a half, positive a half. We can definitely all agree that it's positive, and a half looks about accurate. It's not overly steep, okay? So just, again, wrapping your head around what we actually just calculated there. And then also, did I show you guys the derivative function on your calculator under the math menu? Like how your calculator will evaluate derivatives for you? So,
What the heck?
it will evaluate derivatives, it will not come up with the derivative formula. So if you ever wanted to evaluate this derivative, the derivative of this function at 2, 2, there's that under your math key, and then here are the prompts. So first of all, when we derive this formula, or this derivative, we're doing it with respect to x, because that's the variable within it. So it's d over dx. And then you would type in your function, so that 3x cubed plus 4x to the 1/5 power. And then there's this little, vertical bar, and then you tell the calculator at what x value you want the derivative at, and we want it at 2. And when you hit enter, you'll get the 1/2 that we just got. So it's a checking mechanism. In the event that, like, when there are calculator sections, if you're finding the derivative, and that's not really the bulk of the problem, like, when you're asked this question, you're essentially being asked to show that you understand how to find and evaluate the derivative. But there will be problems that are much bigger and beyond this, where the point of the problem is not so much can you find the derivative, although you need to be able to do it within the problem. There's a much larger goal of the problem. And so in a case like that, that might be something that's on a calculator section. So if you know how to use this, it's just going to save you a whole bunch of time and not sidetrack you from the actual point of the problem. Does that make sense? So it's just to show it to you, it is a feature. But again, your calculator would never help you come up with the derivative formula. So that's really the 4 examples on the front page are all just evaluating the derivative once you find it. Again, a big takeaway is don't waste so much time trying to simplify and come up with the perfect derivative formula. You don't care to simplify the formula and put it in its most concise format when the end goal is to evaluate. So just plug in 2 right away and then go from there. Okay? Then on the back, we haven't done this in a while, but we've done it before, writing the equation of a tangent line to a graph at the given point of tangency. So anytime you're writing the equation of a line, we need what and what, Lizzie? Right, so you need a point and a slope. Now they're going to give you the point, that's the point of tangency, but you're again going to have to find the slope at that point. So in this case, the slope at 1. So go ahead, get started finding your derivative and try to evaluate your derivative at 1. So there's my derivative without doing any simplifying, then I'm just going to evaluate it at 1. And 8 to the 1/3 power is 2. It's cubed root of 8, so it's 2. So it's negative 4 over 3 times 2 is 6, which is negative 2/3. And that's our slope. And we have our point. So we'll just write the equation of the tangent line using our point slope formula. Yep.
Why is it negative 2? Oh, wait, never mind, sorry. I was looking at a wrong thing.
Okay. And then we did first and second and third derivatives, but we did not do it yet with trig. So, in this particular case, when I do the secant of pi x squared and rewrite the whole thing, it's gonna end up cleaning up nicely, but in the process, it's gonna be somewhat of a long answer. It's a power rule first, times the derivative of what's inside. Now, what's inside initially is the secant of pi x. And what's the derivative of secant? Secant tan. Times the derivative of what's inside of that, which is pi x, and the derivative of pi x is pi. So your first derivative cleans up to a secant squared, a 2 pi, a secant squared, and a tan. And then when I get started towards the second derivative, what's my overarching rule that I'm going to follow first? What'd you say? Product. Yep. This would be your first, and this would be your second. So you need your first times derivative of your second plus your second times derivative of your first to kind of give you the outline. And that's going to be fairly long, but it will clean up nicely. Okay? And then the last one that we're not going to get to is just evaluating the second derivative at a certain point. So you have to find the second derivative first, and then evaluate. Yep, your homework is at the bottom. Were you confused, or did you want me to show it?
No, I just didn't see it.
Okay, it's there.